So without much ado, in the interest of time, let me call on my co-host to facilitate the Q&A session. Dr. Dixon, the floor is yours.
Yeah, thank you very much, Dr. John Pulhin. And also thank you very much for our presenters, no? Interesting papers. So I think we're going to flash the we have selected the few questions in the interest of time. And I'm very glad to notice that this webinar is well attended, 118 participants. Okay, let's start with the first question. Okay, this question goes to Dr. Comiso. All right, this is from Dr. Mendoza of UP Los Baños. Dr. Comiso, how do you separate or distinguish and therefore measure the anthropogenic component of CO2 emission from the non-anthropogenic measured or collected in the atmosphere? Or measurements for both are done from the source, example, carbon budget. RCP 2.6 and other RCPs are only based on CO2. How about other GHGs? RCP 2.6, which is based on 421 ppm CO2. Can we go back to that first question? All right. Are we there now? The other RCPs beyond 2.6 seems to result to significant temperature increase up to 6 degrees. All right. And then there's another related question from Dr. Diaz. Are we near? No, he's asking about the safe levels. No.
Okay, so
Can we go back to the first slide? Yeah.
can I answer
All right,
that?
yeah,
There,
Dr. Camisa. Yes,
Yeah.
yes. Please go ahead.
there is a natural variability of CO2, and it goes normally from 190 to 290 parts per million. So since the Industrial Revolution, we have been exceeding that regular interval. So from 300, 290 to 300, it increases by about 2.5 parts per million. So whatever is the increase can be attributed to anthropogenic component. Now, separating the two is, I think, very difficult. But what we are looking is just that an effect, the net effect of increasing greenhouse gases. So when you look at the RGP 2.6, for example, what is included is already a combination of the other greenhouse gases converted into CO2 equivalent. Now the question is, are we there now? Do we have 421 ppm? It changes from one year to another. So when we wrote this review or this report, that was about what we thought was the current value is probably higher now. But if you look at the Kyoto Protocol, what they've been asking is to go back in time and get the CO2 level to even the level of the 1990s. But that was not possible to fulfill, and this is some sort of a compromise, I think. And the modeling shows that even if we come up with ability to maintain 421 parts per million, then there are very positive returns, so that we get that increase in surface temperature to level up, and we avoid getting the Arctic ice cover to become a blue ocean in the summer, and we avoid ocean acidification. So that is already a big benefit. I think the less amount of CO2, the better, because then maybe we can reduce the warming a little bit. With the 2.6, what it tries to do is to get the level of temperature to approximately the same as what we have now. Did I miss anything?
Yeah, yes, yes. Okay, thank you very much, Dr. Comiso. Uh, let's look now at the next question. All right. Yeah, here is for Dr. Maud Latif from Dr. Diaz. What is the estimated cost saved in the initial reduction of air pollution level due to COVID-19 lockdown in your country? You have mentioned. And the other question is, in your analysis of air quality in Southeast Asia, from Mr. or Miss Okiyama, I would like to ask whether you have seen a relationship between the number of mortality of COVID patients and the air quality. Is there a distinct or interesting result that connects the two? Professor Dr. Latif?
Okay, thank you very much. I think there are many research questions that we need to answer from the COVID-19 pandemic and its relation to the air pollutions. I think maybe the first one, many researchers actually study on the impact of air pollution itself to the number of cases of COVID-19. In terms of the first questions, I actually don't have any data on the estimated cost, but I think this is a very good questions and very good research question for us to do, for example, especially in the Southeast Asia, where we don't have any data on cost related to the reduction of air pollution. For the time being, I think we can do this kind of research because we have data on reduction of air pollution. So we need to have people in researcher involved with health and related to the cost of impact of health from air pollution to estimate the cost of the air pollutant reduction in the Southeast Asia. I think it can be done, but for the time being, we don't have any data on the cost. The second thing, I think the second question is very interesting as well. There are so many efforts for us to determine the impact of air pollutant and to the mortality. In Malaysia, for the time being, we have data on air pollution, hourly air pollution, and we try to determine its impact to the number of cases, as I mentioned. But so far, we don't have a good result to correlate between the impact of air pollution to the health or mortality. I think we need to be careful in terms of the air pollutant. As I mentioned just now in my presentation, there were several pollutants that reduced. For example, NO2, PM10, SO2 a little bit. But there also increasing trend of certain air pollutants such as surface ozone. So we need to take care, or we need to make sure that we use all the data to estimate the impact to human health. That's my answer. Thank you.
Okay, thank you very much, Professor Latif. Okay, let's flash the next question. Yeah, this is the question from Dr. Mendoza to Professor Reliano. From the top-down approach, On the other hand, my question is similar to my question with Dr. Comiso in terms of distinguishing anthropogenic, non-anthropogenic. If CO2 is measured, collected at the atmosphere, it is not clear to me how you disentangle CO2 into sources. Combustion efficiency is certainly one factor, but are there other factors to consider?
So, so,
Professor Aureliano?
so that's a holy grail kind of question with regards to attribution, because this is really a hard problem because, again, as I said, natural processes dominate, and the anthropogenic activity is only a very small portion of it, although the trend is attributed to anthropogenic activity. So the way that we're doing it from the top down and bottom up is actually reconciling those, and we use the model to actually simulate what we know a priori of this contribution. So we can disentangle it from the modeling's perspective in terms of the contribution of the CO2 sources and sinks, natural and anthropogenic. However, there's also several campaigns and efforts right now to look at what we call tracers of fossil fuel CO2 that is being deployed, and hopefully there will be national networks on this, on the isotopes of fossil fuel CO2 that can actually really is a very good proxy to CO2 from fossil fuel. And so we're looking at that. At the same time, my research group is looking at it from the air quality side. There's a synergy between what you emit, looking at it from a CO2 point of view, and also from the NO2 emissions. Again, efficiency is one thing, but the emission factors is another thing. And so both of this, that's what I would like to emphasize, is that we have to look at it from different perspectives and combine all information that we have, both socioeconomic factors, abundance or measurements in space and in ground and field campaign with and modeling to actually provide a robust assessment. However, we're not there. We're not yet there. Even the Global Carbon Project is still a very hard press to look at what is the contribution of the fossil fuel, not to mention the strong coupling and feedback on the climate. And so I think the short-lived climate species can actually help as well in terms of climate scenarios and so on. But I think we're not yet there. There are some deployments, again, the networks are there. There's even a space-based geostationary proposals out there looking at just carbon staring at one particular region, geocarb for US and microcarb for Africa. So it's evolving in terms of observation system, it's evolving in terms of modeling, and it's also evolving in terms of the social and economic studies out there.
Okay, thank you very much, Dr. Aureliana. Okay. We also see a raised hand here from Dr. Gisela Concepcion. Maybe we can recognize Dr. Concepcion if she has a question. Dr. Concepcion? All right, no question. Okay, I think we can entertain at least one last question. All right. Okay, this goes also to Dr. Comiso from Dave Anastacio. Given that natural variability has been accounted for in the differences in sea level rise, what could be other factors affecting variability in sea level rise, given the assumption that sea levels would be somewhat evenly distributed globally? Yes, Dr. Comiso, the floor is yours. Dr. Comiso? I think your microphone is muted.
So can you
Okay,
hear me?
okay. Yes, 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 Dr. Comiso. Thank you.
Yeah. Okay, so this is a question that the researchers are still trying to pursue. And the one that I showed you earlier about looking at the effect of natural variability as could be caused by El Nino and similar phenomena showed that what we see as special variability in sea level rise is reproduced, and it was even made worse near the Philippines. So there are many other factors, but they're normally very hard to investigate. There are processes that affects the atmospheric circulation as well as ocean circulation. And it's not known whether there's large variability in those regions where you have an enhancement in sea level, rate of sea level rise are going on. So the fact that the phenomenon is repeated with and without removal of natural variability is a reason alone that we have to worry about it. And the fact that in Manila, the sea level rise problem is even more serious. Part of that is likely attributed to the sinking of due to the susceptibility when they extract a lot of water from the bottom. So it's compounded by that, but as you see, the impact of circulation is apparent because it happens for a large area in Western Pacific. So sorry, I can't really give you a down-to-earth answer to that question.
Okay, thank you very much to our panelists. And in the interest of time, we still have a second session. So we have few more questions, but what we're going to do is to take note of all your questions, collate them, and send them to our panel presenters, and you will get a response from them. No? So thank you very much again for your active participation, and I'll give back the floor to Dr. John Pauline.
Thank you.
Thank you.
Thank you very much, Dixon, for facilitating the first part of the Q&A. Now, moving on,